All right, so today we're just going to do a little engineering report document. We've got a report that we've gone back and forth on a couple times, and it's looking quite good. I hope the lawnmower running outside doesn't overpower my voice here, but here we go. So this is our mobile renewable energy trailer, and I guess what I'd like to see on here, I'm just going to show you how to put a picture in. And then, but what I'd like to do is see, well, we could probably even use this one, but, so I'm just going to go right here. The mouse can kind of be anywhere. I'm going to go ahead and turn on the meta characters with Control-Shift-8, and I can see that, you know, this is fine, that there's all these paragraph returns and all there for now, but in general, we try to avoid those. We try to just put in line spacings. I also try to avoid pre-formatted Word documents and templates because, again, there's just all that code there that you can't really touch. So just being able to see your own returns is a better alternative to that. So we'll insert picture, and I'm going to go to Documents. I'm going to go to Courses. This is from the Practicum, and we first started this project in 2013. And if I turn on the extra large icons, I can see a pretty good photo. And this is what the turbine looked like. The turbine trailer looked like, just kind of freshly finished. That's Tim, Caden, and Jesse there, looking proud with their finished project. You can see right now that the photo itself is in line with text. So I'm going to right-click on it. I'm going to click on Wrap Text, and I'm just going to put it behind the text. So now I can kind of move it around wherever I like, and it's not going to interfere with that text that's already there. And let's turn the meta characters off and see how it looks. One thing I'm also going to do is go in here, Format, crop it. Maybe crop a little bit out here. In general, you're just trying to get rid of this stuff, and I'm not a photojournalist by any stretch, but just you're going to want to get rid of this stuff that's extraneous and distracting. So now I can right-click on that, and then delete comment, and maybe we just take this guy, pop it up there. I'm going to do Control-Shift-E, I think. Control-Shift-E. Let's click there. Normally it's Control-E, hang on. Control-L puts it on the left, Control-E puts it in the center. So that's just kind of handy. Be able to drag this guy back down here. That's fine. If you want to just kind of get this back down where you had it, just put some returns in, but I'll let you mess with the format. So on the cover, we'll just have this this document or this photo in the background, so it's a good place for it. All right, so summary. All right, and let's look at the page numbers a little bit. So this is going to be, we could even call it the executive summary. First page. That's a great place for this thing. I'm going to do Control-Shift-Enter. Let's get these lists of figures and lists of tables after the appendix. Normally the appendix is going to come first. I'll hit an enter there. And let's also, before the appendix, I'm going to do Control-Shift-Enter, and that's going to put the appendix on a new page. So Control-Shift-Enter.
Is it page break?
Page break. Control-Shift-Enter. Calls it a column break. Same difference. Now, if we look, let's go into the headers. This is section 2. This is section 1. That's a good thing. What I want to do is put page numbers in the first sections, and I want to use the convention, which is to use Roman numerals, lowercase Roman numerals. So we'll do insert. Insert page number. bottom of page, and let's I'll put it here, and then we'll go back in. I'm going to want to right-click on that, format page numbers, and if we click on the format, I'll just do the Roman numeral. I don't think there's a previous section, so let's just put it that way. Okay, so there's.
Does that affect the cover letter or the
very cover page? Maybe I might need to put in a third section. So the cover is one section, the front matter is a second one, and then the body's a third. So that's a great question. Let's take a look at that. Okay, so another thing I can do now is get rid of this guy. It looks like, okay, so now our introduction is page 1. That's perfect. And this is the third page. There's the second page, and it looks like for whatever reason there actually is no page number on the very first page. So I'm not sure why, but that's okay. And sometimes just Word works in your favor. I don't know. It's not there. Okay. So executive summary. Page 2. Another thing we could do. Well, you know what? Let's just do it right. Close header and footer. Let's do Control Shift Enter here, and then Control 8. Oh, I think I see what might be happening. Column break. So I'll delete that one little paragraph. And this is actually going to be now section 1. Oh, wait, no. Okay. Redo that, sorry. Close that. Delete. Here we go. Insert. We'll just put that section break in right there. Okay, there we go. Now, this let's get back into our. Okay, this is section 2, and we'll not link it to previous. Section 2. Not linked to previous for some reason. This is always a pain. Sorry, just bear with me. There's section 1 on the very first page. Fine. Now we're at section 2. That's good. Somehow this guy lost its page number, so let's just put it back in. Let's not link it to previous. Section 2. Different first page was clicked. That's fine. Oh, you know what it is? It's different first page within that section.
Oh, okay.
I think. Yeah. Okay. I think that's what it was. So it was different first page. That's fine, because all we have to do now is go in. It knows that that's the second page in the document, but we need to tell the section 2 to start with its own pagination. So format page numbers. Don't continue from previous section. Start at 1. All right, that's the proper way to do it. So now section 2 starts with a 1. Section 1, which is just the header, which is just the cover page, doesn't have any page numbers. There's 1, there's 2, and now we're back to page actual 1 in the Latin. Okay. That's always just a little bit whoa, but and if you can keep that page number 1 at the top, that's fine. Oh, you got one at the bottom too, don't you? Let's see. Well, I'll let you fix that. Put the page number wherever you want. I don't need to micromanage that. Okay, so let's go ahead and, well, this is appendix. Let's go ahead and stick in the table of contents, because I think you've done a lot of formatting, right? Okay, so let's go ahead and put that in. I can never remember exactly where it is. It might be under Insert. If you guys can find it, just let me know. Cover page, blank page, page break, cross-reference, header, footer, design, no. Page layout, no. References, maybe. Okay, it's under references. Table of contents, and here's where just I'm not going to be that picky about the format. So we just click on that guy, contents. There it is. Pretty slick, right?
Awesome.
So all of your nice formatting is now showing up. We've got 10 sections. The intro doesn't have any subsections, that's fine. The Win system has controller, charge regulator, connections, the PV, shading analysis, nice. And then the dump load. So these, does the Win system, is that the 2013 report? Do you remember? Because we had the 20, we had the, okay, so let's just go ahead and look at that for a little bit of, so if I do control click, that'll take me right there. All right, so again, let's look at this guy, Control Shift 8. This is going to be, oh, is that in a text box? Is it a text box?
No, I just...
What's this little guy? See, I think it's in a text box. So let's not do the text box thing. I'm just going to do Control X here. I'm going to put it Control V right there, and then this box I'm just going to delete. And then this guy. Okay. So this is going to be Google SketchUp rendering of the initial wind turbine trailer concept. One thing these guys did, so the wind turbine laws in the Missoula Valley are very nebulous, hard to get around, and we decided, well, we want to build one anyway. We're not going to put one on a house because we didn't want to get around the permitting and all that. So we decided we'd put a turbine on a trailer, and then we kind of looked at it a little bit, like, well, if you attach it to the trailer, the thing's going to shake and rattle. It might damage the trailer in some way, and the trailer might not be sturdy enough. So the idea, instead of putting the turbine on the trailer, they put the trailer on the turbine. They built that base, cool. And the mass of the trailer is actually holding the whole thing down. Brilliant.
Yeah, and the shaking with the tires, that's kind of like a rubber dampener.
Shock absorbers right in the tires, and we've got these tie-offs. And okay, it rattles a little bit, but anyway, you gotta hold it down somehow.
Yeah.
Initial Google SketchUp, not ketchup, rendering of the initial wind turbine trailer concept. Note that the trailer's tires and suspension, and thus the entire mass of the trailer. And I'm going to have you try to find the mass of the trailer, because this is an engineering document. We should really know how many kilograms that trailer is. Tim might know right off the top of your head, off of his head. So don't spend 3 hours looking for it. Just use your time wisely. And that's the entire mass of the trailer. Holds the system, or just say secures the system. Now here's another bit of engineering I'd like you to do. Someone might say, well, gosh, what's the maximum width? Like, it's not bolted to the ground, right? It's just gravity holding it there. So a nice engineering answer would be like, could a tornado pick it up? Well, maybe. Probably. A tornado could pick this whole building up. But you should be able to know what the rated capacity of this is. Would 60 miles an hour blow the whole thing over? Is that something you think you could do? I'll show. Well, if not, I'll show you how to do it. We'll do that math here in a little bit. Okay. Secures the system up to a X mile per hour wind. So, and this is not something we really thought about initially, but it's something we should put in there. So, in fact, let's just do that while we're thinking about it. So, view, navigation pane. I think there aren't there some calculations in here in terms of the wind drag. Let's just take a look.
So you'd have to know the force of wind,
Mm-hmm.
tipping point of the trailer.
Mm-hmm. Why do we not see drag in here anywhere?
Look at me, I'm trying to play engineer.
It's okay, man. You do have to know that, yeah.
Let me figure out the pitch of a roof.
I'm almost positive that was in the 2013 document. Let's just take a look. Horses, 90. The system. Well, I know I ran the numbers with these guys. Huh. Oh. Yeah. Where's the limit? Wind speed. Okay, you should be able to use. You should. For some reason, they don't have these their equations here. Moment. Yeah, that's. We ran the numbers that year. But let me just put that in. Connections, theory, rated power, wind turbine. Yeah, so this first section really should be a lot longer, right? The wind. I mean, it's only. In fact, let's just go here, connections, and then. Let's do this, and then if I go home, I'm going to turn this into a new heading. Wind drag wind drag theory. Okay, and then now we can get back into body. And there's, if we go out here onto even Wikipedia, we'll have something. Wind. Here's what we're looking at. There's just and you've probably seen that before, right? From power, but Really, from power systems, from wind theory? Okay. Well, so this is your drag force equation, and let's just go ahead and use one of our equations. Where would be a good equation? Oh, actually, shading analysis. There's something, right? So we can take this guy. Somehow we lost our tabs. Do you know? Remember the tabs we had in here
And formatting for
the equations? Remember that?
yeah. I thought it was.
I thought it was in
Isn't
there.
it tabbed at 2 points?
Yeah, it was. Let's put them back. Doesn't matter. Here we go. So we're going to put a center tab in here, and then we're going to put a right tab in over here. And so now if we tab there, now the equation is in the center, and the equation number is on the right. Okay, so I'm just going to take this guy, copy it.
I don't know how to put the equation numbers.
Okay. Oh, the equation numbers?
Uh-huh.
Okay, perfect. I'll just do a paste, and the number's there. Did you see it? Okay. So the number is already here, and the way I did that, I'll just review how I did that. I went into review, page layout, insert. Okay, remember we did no, this one. We did insert field, and then in field we went down and we clicked on SEQ, sequence, and then I typed the EQ. Here I'm just going to put in dummy because I'm not going to use it, but I would normally type in EQ for equation, but here I'm just going to call it dummy. I'll click OK, and there's the number 1. So I can take this now, copy it, paste it, and now if I just right click on this guy, there's probably a better character to do this, but if I do update field, then auto numbers, and now I can bookmark those things. So all I've done is I've copied that simple equation. If we go back to Wikipedia, I'm not going to copy that thing. I'm just going to rewrite it, and I'll show you how to rewrite this in Microsoft Word. It's pretty simple. So it's F drag equals, or space equals. Remember, we always have spaces on each side of the operators. 1/2. And I usually do it as row CD A V squared. Let's see if I got that right. 1/2 row V squared. I like to put the V last because V is a much more fundamental independent variable. I mean, the density of the air, can't do much about that. Once the trailer is designed, it's going to have a drag coefficient, it's going to have an area kind of fixed, but it's the wind speed that's going to be changing all the time. So the wind speed is the independent variable that you can do the least about. It goes on the far right of the equation. Is that consistent? Okay. Okay, so now I've got this thing. To highlight these characters so I don't have to mess with the mouse that much, let me make this a little bit bigger. What I'm going to do is do shift left arrow, so I'm not touching the mouse, shift left arrow, control shift plus. And then here I'm going to do shift left arrow, control equals. And then here I'm going to do shift left arrow, and I'm going to run my macro, which is Alt S, and Alt S turns this into a symbol. And to do that, I'll review that as well. You can see this is now symbol font. If I click somewhere else, it's in our Times New Roman. Let me just fix this guy. Shift lowercase. To make that symbol, you're gonna need to know this too for density. So for density, Well, to do that, I went to Insert. Where's macro somewhere? Signature. Oh man, macro. It hides from me every time. I don't want a signature line.
The macros?
Yeah.
Had that
We,
the other day.
we had it the other day too. It just always hides. Table contents, review, mailings page layout. Insert.
Wasn't it a big button?
Probably. It's not on home. Insert. Shade, signature, finger, cross reference, header, footer, text box. Design. Nope. View. Oh, it's under review.
Yeah.
Like, why would macros be under review? I don't know. It just there it is. Okay, so macros. Record macro, and I would put this on the keyboard, and I can actually just, so I'll do Alt S, and you can see that Alt S is the keyboard key. I'll hit assign, I'll hit close, and up here I'll just go home, click on symbol, or I can actually type in symbol, SYMBOL, enter, and then I'll go back to view. I didn't highlight a character, but it shouldn't matter that much. Stop recording. So now if I type in the letter A, highlight it, Alt S turns it into an alpha. So that's how I got that row in there. Okay, so now I can get rid of those extra white
It
spaces.
seemed to me like the other day when you just italicized A, it turned into, well, it didn't, I guess it didn't turn into alpha, did it?
Well, Control I is italics, but I've got that macro which is Alt S, which is symbol.
Oh, okay.
So Alt S is my symbol. Okay, Control Shift A. So according to F and B, blah blah blah. All right, save. Now I do happen to have on my handy dandy computer here a drag force equation calculator. So let me get into that. Structural analysis. Deflection. Wind load. All right, so here's a wind load analysis using the formula we just came up with, and in this case I was using it for a solar panel, which is going to have a certain height and a certain width. The trailer has a certain height and width, and I can give this to you, and you can just play with this on your own a little bit. But I'm just going to take a guess and say that the trailer is 2 meters tall. It's going to be a little more than that probably, but again, you can fix that. I'm going to say the width is, not quite 5, maybe 4 meters long. That's going to give me an area in square meters. This angle is the, well, it's the angle of the panel. In this case, the trailer is vertical. I think a 90 is going to max this thing out. Let's just check.
Yeah,
Yeah.
because that's really what's going to flip it. It's just a 90-degree
Yeah.
wind gust.
Yeah. So there's 90 degrees. So the sine of 90 is 1. Cosine of control 1 on that, turn it into a number, and it's 0. The drag coefficient, let's go back into Wikipedia just for a little bit, and let's look at drag coefficient, dimensionless number. So if we look here, long cylinder, short cylinder, so you can actually get drag coefficients up above 1.5. A cube is 1.05. So I think in this case the drag coefficient is taking into account the fact you've got drag, not only pressure hitting the front of it, but drag on the surfaces as that wind goes over. So a stop sign, like a one-dimensional stop sign, if I'm not mistaken, has a drag coefficient of just 1. And the reason this this short cylinder, I think the long cylinder is actually a little bit
More aerodynamic than lower the.
Yeah, exactly. So this streamlined half body can get pretty low. We're just going to go with the cube for now, 1.05.
So a parachute would have like a negative, or very high.
Very high. Yep, exactly. 0.05 drag coefficient. There's the density of air. So the force now, what we're looking at is in a, let's just say 60 mile an hour wind. Here's our 60 mile an hour wind. I've got the force in pounds and also newtons. We're looking at 800 pounds of force pushing on that trailer. So as long as, and the, we also have a friction coefficient with the ground, right? At some point that thing starts sliding. And if we just assume that friction coefficient is 0.5, then, and let's just say the trailer weighs 2,000 pounds, tons, probably a little more than it weighs. That means that it would take 1,000 pounds to push it if the drag coefficient is 0.5. So at 60 mile an hour wind, if these numbers are right, we're getting pretty close to that 1,000 pound force where you can actually blow the thing along. So run those numbers, long story to get that number, but that's kind of what you're looking for right here. See that? And then you can, you should be able to, okay, and again, these figure captions go below the figures. Does this guy have a, yeah, okay. Is that really the,
Can you go back over how to turn that into a figure again?
this guy?
And to correlate that with the picture?
Yeah. Yeah, so what we've got, let's just go back and review all of our figures. So here's figure 1, and again, the figure caption always goes below the figure. If I can get it down there. And the table captions always go above the table. Okay, so there's figure 1, there's figure 2, here's figure 3. So what I'll do, I'll just put in a new, figure caption. So insert caption, and insert captions that are references. Insert caption. This is going to be figure. Okay, and it's figure 4. It knows that because I was below figure 3. Let's call it the tipping force. Of the wind turbine trailer. Right, because if you're going to hand it, like, let's just say you're going to go and do disaster relief somewhere, and you're gonna pull in, and gasoline is scarce or expensive, so you're going to pull this thing and actually make electricity from the wind and from the sun. Somebody like at FEMA or the Army Corps is going to go, "What are you guys doing with that trailer? It's too dangerous. It's going to blow away." Well, you hand them this engineering document and say, it's safe up to 60 miles per hour. If we're looking at gusts up to 60, we'll hightail it out of here, or we'll bolt the thing to the ground, or sandbag it, or whatever. Make it more massive. But you've got an engineering document to show you, right at 60, that's when the thing might blow away. So, okay. The wind turbine trailer. So, did you see how I popped that guy in there? I just went up to references, insert caption, and it just put figure 4 in there for me.
But how do you associate it with like a picture or the actual.
Oh, sure. Okay. Well, let's go back to Excel. And this is formatted okay. So I'm just gonna click into this figure that I made. I'm gonna right click it, Control C, Alt Tab. So the Alt Tab gets me back here. I'll put my cursor where I want it.
Mine doesn't do Alt Tab.
What you got? A Mac?
No, it's Windows.
Let's
I
go.
to Alt Tab, and
What do you got, like-
it cycles through the tabs.
Oh, really? Within a single application?
Yeah,
Huh.
yeah. It's
So-
annoying.
Yeah, I think Microsoft, man, if it's not broke, don't fix it. I mean,
Yeah.
Alt Tab has been working for me forever. Anyway, okay. So now we'll do home, paste. Let's see, let's do this one more time. Copy. Okay, here we go. So now we're going to paste as a picture. All right, so that's the figure from Excel, and that text is a little bit big. And then here's the struggle, right? So I made the figure smaller, but it also made the text smaller. So what you typically have to do is go back in here and kind of make the font kind of clownishly large. So if we make this maybe like 16 point, looks a little too big there, but it's okay. Font, let's just make everything like, maybe this can be 18. This can be font, we'll turn this into 16. This can be font, we'll turn this into at least 16. Font, 16. One more time down here. Font, 16. Okay. And then that got a little weird on me, so I'm going to go back down here, format the axes, and I'm going to max it out at 100. Hopefully we don't get 150 miles. I mean, if it's more than 100 miles per hour, you might as well forget it. So now what I've done is utilized I've utilized the white space. I don't have a whole bunch of extra white space kicking around in there. So I'm going to now again right click, copy, Alt Tab, delete, paste, special. It's giant. I'll shrink it down. That's okay. Okay. Now I think your question is how do you associate it?
Parentheses is missing.
Right. Where'd the figure caption go? Right. So I'm going to go back up to this paragraph, and I've got my. And you just kind of have to decide: do I want this figure in line with text? Right now, it's in line with text, which it's fine. It takes up more space, but that's all right for now. I've got the cursor right here in the paragraph. I'm going to click in this paragraph window and do line and page breaks. Keep with next. Okay, now it hopped over to the next page. Now I got a bunch of white space up here. If I make it smaller and smaller, eventually the whole thing hops back up there, right? And that's something you do at the very end of formatting.
Keep with next. The picture
Keep with
keeps
next.
with the figure 4.
Yes, so this is one paragraph, because you can see the paragraph symbol.
Okay.
The figure caption is another paragraph, because you see its paragraph symbol. It's just telling me keep this paragraph with the next one. We do the same thing with the
Keep with previous? For the
yeah, maybe. I try not to keep with previous.
Oh, okay.
I try to only keep with next. I try to just do the proper spacing above. You got to kind of pick one or the other, because otherwise they start kind of fighting with each other. So I only use keep with next, and I only put spacing before,
Okay.
never spacing after. Speaking of which, if we look at body, let's go to body and see what kind of yeah, right now there's no spacing before body, and I kind of like a 3-point there. So I'm going to hit OK on that, and then I'm going to click on Update Body to Match Selection. Oops, no, body. Okay, there we go. Now, for some reason, yeah, our tabs got kind of messed up again, didn't they? Oh, because it's body. Let's just go to normal. Yeah, the tabs are missing, though. That's weird. Okay, here's what I'm going to do. Let's make an equation-style paragraph. So the equation-style paragraph will have a tab in the middle and a tab on the right side. So let's just make that, and then we should be able to go back. Okay.
Didn't you make one that said equation?
No, I didn't, and this one's kind of messed up too. So here, okay, this will be a great exercise. So let's take this guy. We'll put our We'll put our center tab back in the middle, like 3 1/4. And we'll put our right tab over here. So the tabs are there, they just kind of disappeared on me. I'll save it, and now I'm going to go in and create a style, and I'm going to call it equation. I'm going to hit OK. There it is. I got a new style called equation. Now if I come down here, I should be able to click that. Equation. Nice. Now it's not going to put the tab in for me, but it's going to know that if there's a tab there, it's a center tab. So that saved a little time there. Same thing here. Let's call it an equation. It's got the tabs in there. All we got to do next is copy this guy. So I just copied the whole thing. I pasted it. Now if we stick our tabs in, it's right where we want it, and we'll save it. All right. So okay, this is fun. Was that guy? Okay. Oh, we missed one right here. This guy's got to become an equation too, also. Update field. Now, I think there's another way to update fields. Let's just see if we can find it. I think it's like F9 or something. Update fields in MS Word function. Automatically updating fields and links. And usually these Office articles, they're getting better. See this thing where see where it says F9? I think that's it. Let's just take a look at it. Remember I showed you EndNote last time. I think that the F9 would toggle between showing the code and what you actually want to see. So let me see here. F9. This is actually a pretty good page right here. Let's just find F9.
Ooh. Email that to me, would you?
This one? Sure.
Yeah,
Okay.
please.
Yeah. Refresh. F9. I don't know. Okay, refresh. To insert special characters, a field is Control F9. Insert an empty field, Control F9. Update selected fields. Unlink a field. Ooh. Let's just see if we can go here. If I click this, let's see if I hit F9, what happens? Oh, it worked.
Update?
I clicked. No, I just clicked F9.
Oh.
Yeah, easier than right mousing around. Another way to do it is to print the whole thing. If you print it, it updates all the fields too, all the figures, all the equations.
If you print it, or if you just go to print?
Go to print even. Yeah, you don't have to physically print it, or print it to PDF, or print preview will do it too. And then when you come back into editing mode, you'll see the revised. Okay.
Very nice.
All right. Typical WinRAG formulas are found according to F sub D equals 1/2 rho C sub D AV squared. Now, so here now we're in equation. I actually want to make a new remember when you hit return from one paragraph, the next paragraph inherits that same style? Where, and actually, so what I'm going to do is, I'm going to fix it right now. Paragraph. Oh wait, cancel. No, here's what I'm going to do. Create new style. And I'm going to call this, I want to call it after the equation, but instead I'm going to call it equation after. Remember the verb order in French versus English, so I'm going to call it equation after, because I'm going to associate it with the word equation. Equation after. And in equation after, I'm not going to have any tabs. I'm going to get rid of those. Tabs, clear all. Okay. I also, this paragraph is still, well, no, this sentence is still part of the paragraph. So in fact, it's the word where is still part of this sentence and part of the paragraph. It should not be capitalized. Where rho is the air density, C D is the drag coefficient, A is the frontal area of the object, and V is the wind speed. Okay. So here's and I'm really not a big fan of how the new equation formatter works. So right now we don't actually have an equation in there. There weren't any fancy summation symbols or long division symbols. So that equation is just font, and normally that's the case. If you have to get fancy, then you can insert an equation. But now there's probably a way in styles to allow this, well, to tell Microsoft Word to not capitalize the first line. You can figure that out. But this is the proper way to do it. So now this is called equation after, and it is not indented. The body text is indented. All right. This guy, Control E. And the easiest way to do the figures is just in line with text right down the middle. You can't go wrong with it. You won't have to mess around with things too much. That's the best way to just kind of keep things for now. All right. Now what I'm also going to do is come in here and references, or I want to put in a bookmark. So insert bookmark, and I'm going to call this drag. AERO, add. Okay, so now later, if I want to reference, and I think we had a question, that's what I was looking for. I thought this equation was in this report already. I was surprised that it wasn't, because it's fundamental to aerodynamics. Now, anytime we want to use this later, we just reference equation. So if we wanted to say, and I'm going to delete this, but if later in the document, as shown. Oh, you know what? No, let's do it this way. This will actually be a good next step for you. You can go into that 2013 report and see if they did it right, because I was actually having them try to calculate the the bending moment on that main post, because you don't want a little whippy little tiny one. You don't want something that's gonna break. So we had to figure out how thick does that post need to be so that when the wind blows it doesn't bend it over. I think it's a little overbuilt, but that's another good engineering exercise for you to do. So that'll be your next little assignment in here.
Wouldn't that also depend on how much, like, the faster it goes, the more friction inside the turbine that happens, the more, I guess, thruster would happen.
Yeah. Well, right, exactly, and this is it's the same thing. So like you said, the faster the wind blows, the more moment there is on the thing.
Mhm.
You know, just imagine a flagpole bending over in the wind, or a mast on a boat. Same deal. Yeah. So
And the faster the turbine goes, it would actually start to, like, it wouldn't just keep going faster and faster. Eventually there would be some kind of slowdown in momentum, I would think.
Well, that's another good question. So any rotating machinery is going to have a stall torque. You know, some torque over which it has to overcome. So if little tiny gust of wind probably wouldn't get the thing spinning. Once it's up to speed, yeah, there's a max speed after which, and that's called the, gosh, I'm trying to remember the name of it, but that's the max RPM, if you will, where there's not enough extra wind coming in to make it spin any faster. You know, it's the same when you wind out your engine. It's the same when you're pedaling your bicycle. I mean, your legs can only move so fast, and at that point, there's really minimal torque on it. So at the beginning, there's maximum torque. At the end, there's minimal torque, and in the middle is the power curve. We don't have that in here, but we do a lot of that in our car competitions. So what I'd like you to do is go in and see if these things are correct. So let's do it this way. So this will be body. So again, according to, here we go. So insert, cross-reference, bookmark, drag arrow, insert. So we just put that in there. Now we're not going to have to mess with it again. It's going to stay according to one. And using the equation for moment.
Mozilla have a wind tunnel?
Yeah.
Really?
Yeah, there's a couple.
Yeah.
Out the fire. Yeah,
test it out.
yeah, for sure. Del equals F times R. And I'm going to make these guys, so I like to use tau for torque, and I'm going to make it bold. And these are vectors. Have you studied vector? Okay, so that's a vector. A lot of times the vectors are not italicized. I actually like it better that way. Control B. Oops. Control B. Control B. Then moment at the base of the turbine tower is, and then you're just going to put in a number here. And what we'll also do is, let's just go ahead and I'm going to grab these. And again, this when I was first teaching this a couple years ago, you can see that I didn't exactly get my point across because the chart is labeled as force delivered to base, but what is it? It's the moment, right? Two very different things. You know, force is how hard it's pushing, and the moment's how much it's bending. So this is going to have to be fixed, but I'll put them in as placeholders anyway. So there's a copy. There's a paste. So I'll just say fix. And you'll be able to use that same that Excel that I just gave you.
So a moment is when force turns into kind of like braking power?
No, well, you could think of it, if you're putting a disc brake on a rotor, but the force, you know, it's probably better if I just show it this way. So yeah, but if you've got a something, So here's your rotor, here's your wheel, whatever it happens to be. It's on an axis, and there's the center. I can push with a force here, and it's going to make it rotate, right? So with a large force and a small moment arm or a small radius, so big force, small radius, I can make a torque. I can make the same amount of torque with a smaller force up here and a longer moment arm. So that's torque. You can, you could think of that as just gears.
Okay.
You know, that's why you have gears in a car, because your engine's going to only make so much torque, and in low gear you're going to want a bigger sprocket in the back. You know, so just think bicycle. The force is whatever tension is in that chain, and then the torque is that tension multiplied by the radius of the gear.
Oh, okay.
Yeah. So fix that. Okay. So we put in equation numbers. We put in some figures. We've got a table of contents. We know that we need to expand this first section. Add some theory in there. This is fine. Table 2, that's looking great. This table looks really nice. You're gonna calculate that number and put it in. This has to be fixed. Yeah, somebody's partying out there. Another, yeah. Here's another subtle point. This figure that I just put in does not have some heading. Microsoft Excel likes to put these headings in. No. that information is in the caption. If it's sitting up there in the heading, it's just redundant and distracting. This is the better way to make an engineering. And also keeping those lines off the edge too is much better. Just cleaner. You don't need that silly line around the edge. Okay, so there's some PV. We have an equation. So now if I go here, I should be able to click on equation after. Magic, right? Fixed it. Whoops, here we go, watch. Home, equation after. You could even make a macro for that if you wanted to. You know, control, well, whatever. Name your button. Could be equation after. Same thing here. Equation after. Alright. So conductor sizing. This looking good. Therefore, oh, here'd be another one. Here'd be another one where you get rid of this. Well, there really should not be a space between the therefore and the equation. You know, so I'm going to delete that. And if you want them on separate lines, I mean, that would be a perfect place to put in paragraph keep with next. And even this is just, there's just a lot of extra white space in here. And something like this, I'm not sure if it deserves its own line or not. Why is this being divided by 0.87 twice? Have you looked through this technically at all? Because I've just been doing format. Okay, let's take a look at the technical content then. So, conduits are not roof mounted for this project. Therefore, no ambient temperature adjustments for circular raceways exposed to sunlight are applicable. Oh, wow. So these guys are kind of getting down in the nitty-gritty and wondering whether the resistance of any material is going to be temperature dependent, and that's so they're going to see, gosh, if I've got hot copper up there, it's going to have a different conductivity. DC conductor ampacity ratings are derating according for ambient temperature, which from Missoula, Montana, is 0.87 with a 90 C degree rated conductor at 41 C. The ASHRAE 2
90 degrees C rated, as in Celsius rated?
Celsius, yeah. I think this is when the stuff breaks down. I mean, that's its melting temp. That's you can't maximum 41 C. And that's kind of hitting about 100 degrees Fahrenheit. The ASHRAE 2% at this site. From table NEC. So here's your NEC table. You can look that up. Has a temperature correction factor. Problem is they're not showing their max current here, are they? All right, we'll have to go back and talk to the authors on that because I don't see an actual value here. Do you? Or no, there it is. IMAX is 4.5. Okay, let's think about this. I have to go back into my.
Okay, so
We'll want to read through this and see how the ampacity is affected. So, because I think basically the way it works is the hotter that wire gets, the less current it can reliably hold. But the .87 is throwing me off a little bit.
0.87, is that from some kind of study from U of Oregon? Where's that to referencing? Or is it just on the page somewhere?
No. Oh, I see what you're going for. They must have gotten this. Oh, maybe we'll take a look at it. Enroll. Good eye. Acceleration mode. Yeah, I'm not. Photovoltaic data, software tools, sunpad, sundial, PV watt, information. Somewhere here they must have a derater. Yeah, I'll have to go back and look at that a little bit. Okay, PV module.
Use Dropbox?
I guess if I have to.
Oh, okay.
Here's another one where we can do Control-Shift-Dash. Non-breaking. There's no like this. This should be lowercase. Let's try it. Okay, so they're just looking at voltage drop through their system. This guy, are you putting these references in yet at all?
No.
Okay.
Because you're using.
Yeah, don't bother using EndNote for now. The best and what they've done here is put the references in as author year, and that way, when you get a new reference, you can just go into the reference section. So you can just you can just kind of ignore this part. I mean, this can just kind of go away at the end. I was just kind of showing you that. But if we go, and their report will have this full reference. So I'm gonna copy it. I'll go back up to view. I'll split the view. So I'm still in the document where I was. I'll go all the way down to the references. So now I have a new reference. You just put it in like that, and then just copy paste it. Okay. So I think the next step really is to get that 2013 wind report in here in whatever form it is. There's going to be a few things to correct. We already saw a couple there. The difference between torque and force needed to be corrected. We need to update the Excel chart so we know how much drag, and get the dimensions on the trailer so we know how much force it takes to blow it over. And then I emailed Tom about a camera, because I'd like to have a camera to take some pictures so that we can take this. Why is it pink? You know? It must be pink because I've got this label. Once that's gone, it won't be pink anymore. Here, I'll put it down here. Oops. Delete. There we go. That's better. Yeah, much better. Oh, okay, so you've got your AC power, DC power. Oh, nice. Okay, sweet, good. Yeah, the control. Let's go with thicker lines, a little bit thicker, and let's also use dash lines for AC, or whatever the standard is. And here's the reason. Well, the reason you use thick lines rather than thin ones, they're just easier to see, and because when I was in college, I had this engineering professor. He'd always say, "Thick black lines, thick." I never forgot that. So thick black lines are better than thin ones. They're just easier to see, and the reason for using a dash line instead of two, solid lines for both, is if you print the thing in black and white, you can still read it. So just think of somebody printing this in black and white. Think of somebody who's colorblind, and just so make them thicker and make them different shapes, not just different colors. So okay, and then and we'll make sure that this table doesn't break across the spaces. So is that enough? Is that enough to get going on? Okay, all right. Okay, so I'm going to stop the recording. I think we did some engineering things, some
Christmas music.
Christmas music gone, we had weed whackers gone. But so I went over how to put equation numbers in, how to reference bookmarks, which were the equation numbers. We did keep with next on the figures. We copied and pasted from Excel into the document as a picture, not as a editable Excel figure, because that gets messy. We put the table of contents in. That'll update every time. I showed you a couple styles, so we added an equation style. What I'm curious to see is if those styles follow this document, or if I'm going to have to give you another file off my computer somewhere so that you have those. Do you understand what I'm saying? So let's have you open it on your machine and see whether or not that's the case. But I think, was that a good review? Okay.